control device is another necessary component of a circuit in the automotive field. And so we're going to look at some of those now. Here's an example of a single pole, single throw switch. When you draw a circuit for me in automotives at SECHS, you're going to draw it similar to what you see here. There will always be a box around the switch, and you'll see where current comes in through a conductor into the switch. This is the arm that can move back and forth, and you'll also show where current can flow out of the switch, where current flows in through the switching device and then out through the switch. So this is called a single pole, single throw switch. You would turn something on or off. So you physically have to lift up on a switch and then let go, and it stays in the off position, which would be out this way. And then you do it the other way and it goes down. Single pole, single throw. The next one we'll look at is a single pole double throw. So current is flowing in this side of the switch, and from here it could go one of two ways. It could go over to this direction and out, or it could go to this direction and out. An example of this would be a dimmer switch on headlights, where you would have one side that would be low beams and one side that would be high beams. Another switch is the multiple pole, multiple throw switch. It's pretty obvious what this one is. This is your shifter switch. Current will flow in here and goes either to whatever position you're at. So if you're in reverse, current would flow to reverse, and then it would have another wire coming over here, probably going to your reverse lights. Or you might have one coming down here to neutral or drive to tell the vehicle some other things to do. So multiple pole, multiple throw switch. Multiple pole and then two throws. Whenever we have a dash line here, that means when this one turns, this other one also moves alongside of it. That's the multiple throw part of the switch. Momentary contact switch. Current flows from here and up to this little pointer right here. This is a spring, indicating a spring, and when you push down on this button, this whole upside down T here comes down and makes contact with this arrowhead and that one. And so current flows in up to here. When this is pulled down, then current flows across the T over to this side and out. It has a spring here to indicate that when you let go, then this upside down T comes back up and current stops flowing through the switch. An example of this switch is a brake light switch or a horn switch. Another type of switch is a mercury switch. This blue element here is mercury, and mercury is a conductor, and we would use these typically on like a trunk light or a hood light, where as soon as you open it, then the position of this glass bubble changes, and then mercury goes from this side and flows all the way down to this side. And because mercury is a conductor, then current would flow in and then down through the switch, through the mercury, down here, and very likely it'd be a light bulb or something on this side. Coolant temperature switch. Remember I talked about resistance, and the resistance changes when the heat changes. In this switch, there's two little strips here. This is called a bimetallic switch. And when those two little strips, which are made of different things, expand and contract, then this whole tab here bends. And in this case, what it would do is it would bend over and make contact between these two things right here. And then current would flow in, down this bimetallic strip, over and down, and it would slid over, contacting here, and that goes out to a ground, very likely turning on a overheating switch of some sort. We have a temperature sensitive time delay switch. This gets a little bit more complicated, but let's look at this. This is also a bimetallic switch strip, and that bimetallic strip, when it gets hot, it bends. And when that strip bends, it will come down away and removing contact between these two purple contacts right there. And so current flows down, comes from the battery from another switch and comes down through this wire here into this element right here. And this element is a heater element. And so as current is flowing through this element, current is also flowing through this strip. Now the element gets hot, and as it gets hot, this strip will move down. When it moves down, these two contacts right here release, and then current can't flow up there anymore. And it comes down until we turn a switch off. It's a time delay switch. We also have a flasher, which looks very similar, but it is slightly different. It works on its own. And an example of this would be your signal lights. Current flows in this side. It goes down through these two contacts in this bimetallic switch, flows down through the heater element, out, up, and very likely to your signal lights. Whenever this heater element is on, this bimetallic switch slowly warms up and moves down. When this bimetallic switch moves down, it loses contact on these purple contacts here, and then current stops flowing through the heater element. Therefore, it cools off, and the strip moves back up. That clicking sound you hear from a flasher, that's exactly what is happening. This little bimetallic strip is moving up and down and up and down. And this is another type of switch. It's got a wiper resistance right here, and so what happens is current flows in one side and around and out here. And so as we turn the switch, an example of this might be a dimmer switch, or it could be some kind of variable resistor. So when you turn it this way, then we have more resistance, and we change the resistance. And those are our switches.